Hello, I'd like to go over the chi-square test and how to do it in SPSS. It is a test of association using frequencies, so categorical values. And this is just a reminder to me and hopefully to others that it might be useful for others about how to do the test, the chi-square test in SPSS. So one way to put the data, the categorical data, is to say, for example, this particular case of particular cells, they're collected from two different genotypes, wild type or knockout. They were from awake or anesthetized animals, and the cells were uniorientational or biorientational. So the variable view is here, and you can see there are three different categorical through different categories, and then what we can do is, if we have a few thousands of cells, we can continue filling in manually here all the data, knockout, next cell down, then a few thousand years later or cells later we may have finished. Now, you don't want to do this if you have hundreds or thousands of observations. What you probably have already done is know how many you have, like 10 of this type, 20 of that type. And so this is another form of table. I'm going to show you the alternative, and this is a more sensible way to do it. Here are the same categories: genotype, awake, and orientational. Cells, biorientational, uniorientational. But here we've added a fourth column which has a frequency, and it's slightly different arranged, so arranged in a different way. So variable views here, and this will show us the variables. Here's again genotype, awake, and biorientational. However, now the variables are coded. And so here, for example, is the variable for genotype. 1 stands for wild type, 2 stands for knockout. So awake is here. Once again, 1 stands for awake, 2 for anesthetized. And biorientational, once again, here are the values, and the values are 1 for biorientational, 2 for uniorientational. So we have a fourth category here, that's frequency, and that's numeric. It's not a categorical. It's not a categorical value. It has actual numbers that can go up. They are frequencies, so it can go up to any value. And so this is a different way to do the chi-square test, which is much more practical. And so what you have to do first is go here where it says data. Under data, sorry, at the bottom there's weight cases, and normally this was here on the left. We take it from the left, we put it to the right, and this field here that was previously empty, and we'll press OK. I have to do it again because I have already done it. So let's start again. So data, weight class, and press OK. Now a new output sheet is being opened, and it says that weight is now by frequency, and SPSS knows that it doesn't have to do what it was doing before, but now the numbers have been already sort of summed up here and on the right. And we have three categories. Each one of them has 2 levels, and so we have 8 possibilities, 8 combinations. So we have genotype 1, awake 1, biorientation 1, or any of the other combinations, a total of 8. And for example, the first row has the genotype of 1, that's wild type, awake 1, that is awake, and biorientational 1, that's biorientational. So there were 17 observations, 17 cells of this particular type. Then the second row has genotype again 1, so wild type, but now awake is 2, so this is anesthetized. And then biorientational is 1, so still biorientational. There were 8 of those. So 8 observations, 8 cells of this kind. And then next one, and so on. There were 34 for the next kind, and 3 for the next kind, and so on. Now you don't have to put the totals anywhere. Yeah? The totals calculated by the program. So that was one thing that I was uncertain about at the beginning when I was trying to do this. You don't have to put the totals, like how many there are in total how many of this category, how many out of how many. For example, there was 17 bi-orientational and some other number uni-orientational. What is the total? You don't have to add totals. The totals are taken care of by the program. So that's one thing that's a possible confusion. At least I wasn't sure. And how we do now the test is we don't do, there are two possibilities to do a chi-square test. One is, I'll show you where it is. One is down here, non-parametric and legacy dialogues. There's here, chi-square test. Okay, that's one way. The other way we're going to do it today, however, is we're going to go here. There's a chi-square test here as well. Here you have two options. And sorry, did I make a mistake? Try again. Discrete statistics, Crosstabs. Here we are. And so we can do a chi-square test through the Crosstabs. Okay, so I'll show you how I did it again. So once again, we go to Analyze, we go to Descriptive Statistics, we go 1, 2, 3, 4 down to Crosstabs. Click on that. And if you click on Statistics on the right, you see there's an option to do chi-square test, which I have clicked. Continue. And so these values were all on the left. Sorry, I made a mistake. And what you have to do is then select the variable that is of interest to you. So I want to know how many bi-orientational or uni-orientational cells are there and the different in the other categories. So if we look at neurons according, or cells according to other categories, how many of them are bi-orientational? How many of them are uni-orientational? So for example, let's see how many of these, put them under columns, are in the let's say in the awake versus anesthetized category, so called the awake category. So some of these cells were collected from anesthetized mice and some from awake mice. And so here is so the two comparisons we want to do, and in addition to the statistics, we want to do the chi-square test. We want to look at various parameters and have an output. So we can have the observed and expected values, and standardized or adjusted standardized, whichever you prefer. I don't know what the difference is. Some people prefer one or the other. I have to check what it is. And then you have to have here display clustered bar charts clicked, so we can get a graphical output. So we'll get also some bars showing our values in a graphical way. So click on that too, and then press OK. And what we have now is, if we go to the top, so we have, as you see, weight by frequency. We've done this Crosstabs, and we have a chi-square test. And the first table here shows the total number of observations, 178. That's basically it. And the second table is slightly more interesting. So in the second table, the numbers of cells are subdivided into awake versus anesthetized, and bi-orientational versus uni-orientational. So awake, bi-orientational, there were 44 of those in total in our sample. Awake, uni-orientational were 89. Yeah. Anesthetized, bi-orientational were 11. Anesthetized uni-orientational were 34. The total was 178. So that's just the layout of the numbers, the frequencies. And now let's have a look at the results of the chi-square test. Let's go to the graphical output first. Let's see what that looks like, and then we'll see how statistical these differences are, how significantly different these differences are with statistics. So in the case of the cells in the awake category, we have the bi-orientational ones in blue and the uni-orientational ones in red, and we can kind of eyeball this and say that about a third of the total are bi-orientational, the blue, and 2/3 are uni-orientational, the red. This is for awake. For anesthetized, we have fewer observations. However, if we eyeball this again, just roughly, we have about these are the bi-orientational in blue, and the uniorientational in red, there are about 3 times as many uniorientational ones. So about a quarter of all the neurons were biorientational and 3/4 were uniorientational. So the proportions are different. This is 1 to 2 and this is 1 to 3. Is that significant? Yeah. To do that, now we have to use the chi-square test, and we have the results already in front of us here. So this is the Pearson chi-square test, and we have a value calculated by the algorithm, 1.175 with 1 degree of freedom. This corresponds to the significance of 0.278 with a significance value of at 0.05 probability level. So the Pearson chi-square test, the chi-square test tells us that the differences were not significant. Yeah. So there's different proportions. This one versus that one is not significantly different in terms of what numbers we have. Yeah. Maybe if we had more numbers, we get an increased significance. It also depends on things like degrees of freedom. We may get something different depending on degrees of freedom. It also gives here some other tests. For example, the Fisher's exact test is for small sample sizes. But even if we were to say our sample size was a small, which wasn't, still the result would be non-significant. So this is the summary of how to do the chi-square test using a frequency column.